Hello, everyone. My name is Allison Stevens. I am the program coordinator and professor at the Fanshawe College Advanced Ergonomic Studies program. It's a postgraduate certificate, so students like yourself, graduates of the kinesiology program or a human kinetics type of program, join me for a year to learn all about ergonomics. So I want to spend a few minutes this afternoon, this evening, wherever you're watching this, to talk to you about the field of ergonomics. I was very fortunate to spend 30 years at Ford Motor Company as the technical specialist in ergonomics. I'd like to share with you a little bit about what it means to be an ergonomist, easy for me to say, and what I think some of the real exciting opportunities are in the field of ergonomics. So let's go. Let's see what ergonomics has to offer. Okay, so within ergonomics, there are kind of different avenues that can happen. First, there's kind of a reactive, meaning that you are looking for where injuries are occurring. So ergonomics is really about preventing injuries in a manufacturing setting, in a healthcare setting, and in many industries all over the globe. So once you've kind of got an established program, one logical step is, well, how do we prevent these injuries? How do we design out or design into the workspace so that the risk of injury is minimized? And that is what I want to share with you today. I've got a little video here of how at Ford we looked at the future car that we were going to be building, or vehicle, and then made some design parameters and specifications to build towards so that we would have a safe workplace and a safe assembly line. The great thing about our industrial Excellent. Great thing about let's explore a little bit about ergonomics. Now, I know that you have many choices. And what I'd like to talk to you a little bit today is to consider that maybe using your excellent undergraduate degree in kinesiology, which gives you a great foundation in how humans move and their limitations and their capacity, how that will be a very key foundation in the field of ergonomics. So let's go and see what ergonomics has to offer. So traditionally, It's really looking at a workplace and bringing in our kin degree and understanding of the human. We're asked to balance understanding the demands of a job and what a human can and cannot do. And then finding that balance so that you don't over abuse that worker and use it on a repetitive strain injury or at a fatigue rate and exceed their capacity, which would then result in an injury. So we look at the demands of a job and bring those demands down so that they meet or are beneath the capacity of our workers. So there's many aspects of this between analyzing the jobs to understand what the demands are, understanding what the capacity of the human is, and then getting involved in the engineering to make sure that there is that nice balance between the two. What happens when demand exceeds capacity? And unfortunately, this is what's happening in our workplaces. For many, many years, we tend to do a trial and error. We design a job, we put workers on it, and then we get either injuries or we don't. If we get injuries, we have exceeded the capacity, and then we go back and we redesign. So that's the traditional model that ergonomics has played. We tend to be in the safety arena, and we look where the injuries are going. We do accident investigations, and then we assess these type of jobs to fix them and improve the demands of those jobs. So that is very much still in existence. You'll still find that there are many, many industries that are still in this reactive mode. And so there's lots of opportunities there. We are also seeing, though, that people are saying, hey, if we design a job that has this much bending, or unfortunately this kind of access for the human, we may end up with problems. So applying our ergonomic knowledge, the field of anthropometry, the size and shapes, understanding of the postures that people can work in, understanding how strong they are, we can do a better job of designing it right from the beginning. And so that's really where the challenge of ergonomics is to find this balance between demand and capacity. Now, we'd be silly not to start with, hey, how have we been doing out there? How have we been doing on our force? How are we doing on that setup and that reach? Or how are these postures? So by all means, ergonomics still has a very active role in the health and safety field of understanding where our injuries are coming from. The unfortunate thing, or maybe fortunate if you're thinking, is there plenty of work to do, is the musculoskeletal disorders, MSDs, and repetitive strain injuries are still the #1 and leading cause of injuries in the occupational setting. So overexertion type of injuries are really the driver here that are still occurring out on the plant floor. Now, we think, well, why wouldn't companies want to fix this? And they do. Unfortunately, the safety budgets and the workers' comp costs are often not rolled in with the production costs. So a production manager will have their budget and they will not be drained and pulled for the injury costs. So because they're not held accountable for that, what we see is that many industries now still have injuries occurring and still have very fine engineering departments and setup processes. Okay, so this idea then of a traditional ergonomics program, like I said, very, very common in a lot of the introductory type or entry-level jobs will be in this idea of let's see where we're injuring people, let's collect our injury stats. But one of the exciting things, I think, and why I think ergonomics is really taking off is we're now being recognized as part of the design of the workplaces. So we're seeing a move from this traditional safety role into a more proactive ergonomics role. And, a lot of it is the driving of the costs. Yes, we have the injury costs, and they are considerable for a company. But you may have heard of the tip of the iceberg. Below the injury costs, if people are continually getting injured, we have morale issues, we have changes that we have to make, we have to add double person to the things, and we also find a relationship to the quality um, and production loss if the jobs are not well designed to match the capabilities, or what we're calling human-centered design. So I'm seeing now that we've got this new opportunity as companies move to human-centered design. And one of those companies, one that you might have heard of, is Amazon. So even with all of their technology and their robotics, which is a very, very impressive, they found that they needed to take a step back and understand the capabilities of the worker. And so now Amazon has done exactly that. They are expanding, and with that, they are also including within their safety and environmental approach an ergonomics approach. So we're seeing some great growth in the ergonomics area as they want to become the safest, Earth's safest place to work. So this is very exciting for the field of ergonomics. So what it takes is that a belief that we can actually have zero injuries, and we can. We have learned an awful lot about what causes injuries, and if we pay attention to that, we can actually implement. We have to get out of this mindset that production is the number one, so we're going to have zero tolerance to violations that we know aren't good designs in the ergo world. And as I mentioned, this means now we're going to have to get creative as ergonomists. You're not going to be able to walk up to an operator and say, what happened and where's the pain? You're going to have to now work upfront using digital human models and be part of an engineering team. But what you bring to it is your foundation in human capacity. So again, really seeing some big movement in this field. So at Ford, how then did I move from talking to those operators and understanding where they were getting injured to leveraging technology so that we could do upfront ergonomic studies? In order to do advanced or proactive ergonomic studies, I leveraged a technology called motion capture. And what we did here then was we would simulate where someone would have to reach or how they would have to put a part onto the vehicle. And we had to simulate it because all we had was CAD. So all we had was computer-aided design, so digital data. So we would actually bring people, workers, other engineers into the lab, and we would capture their motion to understand the movements that we would expect on the assembly line. Then we were able to reverse engineer and say, well, in this posture, what would be the maximum force that a worker could do on a repetitive basis? So not only were we evaluating the posture, then we were also looking at those forces.
today's standardization is tomorrow's.
So when we adopted this idea of standardization, designing with ergonomic principles, we then ran some early injury stats, and we were really, really overwhelmed with how awesome this worked. And so you can see here we had almost a 90% reduction, 89% reduction in the injuries when we put ergonomic principles in play early in the design phase. So you'd say, okay, we've got it. We figured it all out. Well, it's not quite as easy as that. As work advances, we have new challenges. We have increased productivity. We have new industries like Amazon and warehousing and packaging and deliveries. And so with that, we're seeing new technologies coming in that are helping to improve that productivity, help improve quality, and help with the supply chain. And ergonomics has a real key role of interfacing with these new technologies in order to be able to plan for ergonomics and good ergonomic principles in the design. So one of the ones is simulation. And within the simulation now, once you've got a simulation with a digital human model, you can actually have the computer tell you some of the parameters that normally we would have had to go out on the plant floor and watch. How much time do they spend working overhead? How are they bending? What percentage of the time are they doing that? And then even from a productivity standpoint, what is value add and non-value add work? So we've integrated ideas of postural strain. When someone is completely flexed, it will record, because we're using simulations, the amount of time in those awkward postures. So this would be very valuable not only in the design setup, but then if we do have an injured worker that needs to go back in our return to work process, we can use this information about the jobs and how we set them up. The other element here is because we're now digital and we've got these simulations, there's some new technologies. You're all probably very familiar with the Quest and the Vive headset. Well, you can actually now go within and have a look at what this assembly line is going to look like in the future by setting it up. In this case, we're doing transmission decking, and we could 3 years ahead of time have an understanding of what the operator would see, what kind of postures they would get into. And then we can make the changes before we design the hoist, before we design the assembly line. Very, very powerful. We've also been able to engage on 3D printing. So this is the lug nuts, and you can imagine highly repetitive, a lot of pinch grip. And so we were seeing some carpal tunnels, some tendinitises, and by leveraging now the technology of 3D printing, we were able to do a multi-spindle hand start of the lug nuts. Now, good engineers will say you couldn't possibly get to the required torque, and that's true. The process is to hand start them and then come in with a power tool to make sure that the quality level of torque that's required. But this 3D print tool eliminated the need of the hand starts. And as you can imagine, there are 6 lug nuts on every wheel, and we do a vehicle a minute. That's an awful lot of repetitions that we've just eliminated. So the role of the ergonomist is really as part of that engineering team. We're seeing an influx of robots. The Amazon group shows a lot of that. They really have leveraged robotics. One of the exciting things about robotics is that the ones are going to have sensors so that when they come in proximity of a human, they slow down. But what it means for ergonomists and as part of a design team is we can get at some of these difficult to reach things. Although it makes sense that we would try and keep things close, when you have so much diversity here on the parts, different colors that you have to pick, it's hard sometimes to keep everything within the work zone and the reach of the operator. So utilizing a longer arm of a robotic um, is a great way to do that. Robots not only can have maybe longer reaches than our workers, but they are also stronger. So I love this little YouTube where our worker goes head to head with our collaborative robot called Digit. So our engineering world definitely is looking at introducing these robots, but the role of the ergonomist is to understand when the worker will get fatigued. What kind of actions will introduce fatigue to our workers? And in those cases, then working with the team, look at and decide that a robot is a better choice than this. I often get asked, do I feel that the robots are going to overtake the jobs? And the answer is no. The robots need to take the dirty jobs, the ones that are really hard to do and that are causing us injuries. But the high finesse ones and the ones where we need the multiple decision making, we will still keep to the workers. All right, looks like Digit's winning. All right. And here we also see some examples of not only just a strength and an improved posture, but then on some of these highly repetitive tasks. So the use of these robots then can affect the three main risk factors for MSDs. Some posture by improving some of those reaches, the forces because it's stronger, and these highly repetitive tasks. So the exciting part is I can't tell you all the technologies that we're going to leverage to make ergonomic improvements of the workplace of the future, but I can tell you that ergonomics is at the forefront. So if you're someone who's come from a kin background, you have a great understanding how humans work, you would like to be involved in the prevention of injuries, not only in the rehab, but in the prevention of injuries, then this field is something very exciting. It leverages all these new and exciting innovations that you're seeing here, like exoskeletons, collaborative robots, augmented reality, and it allows us to work as part of that engineering team to find solutions to very challenging workplace problems. So the idea behind an exoskeleton is that the device supports the worker's arms, or in some cases the back, and then reduces fatigue. And we believe that fatigue is a precursor to injury. So a lot of industries are now playing not only with collaborative robots, but also the exoskeletons. I also mentioned that we're seeing some breakthrough in the cognitive side. Um, the time that people have to take to make sure that they didn't do it incorrect, checking back to training manuals, and this can really have a huge impact on quality, the order at which items need to be done. And so we're seeing a relationship now coming in with augmented reality in training manuals, on maintenance, so they know what to do. And this then helps us, the worker, do it correctly, highest quality, and then we can then influence that in terms of reducing the awkward postures, repetition, and again, it's part of that planning. So, what's the future? I think it's still pretty exciting. There's a lot coming out in wearables. You've all probably got your Apple Watch on and monitoring your heart rate and your steps. We're seeing that these wearables are going to help us in assessing the risk. We're also seeing these wearables like exoskeletons. Iron Hand gives you increased force in your gripping force. So I see that many of these wearables and new technologies are continuing to come into the workplace, and what the workplace needs is people like you. So, what is your plan? If any of this is of excitement and you would like to explore a little bit more, I encourage you to look up the Advanced Ergonomic Studies Graduate Certificate Program. Kinesiology is the background that we are looking for, and this is the first of its kind. We have been running now for 5 years, and we have been able to graduate kinesiology students with this 1-year certificate, and they have now entered into this very exciting field of ergonomics. So it's a very intense program. Don't think of it as your college coming out of high school. This is totally geared with an understanding that you have a kinesiology background. It's full-time, Monday to Friday, a blended format right now, but it will be back on campus as soon as we are allowed. When I say blended format, we have been able to run all of our labs on campus, and we will continue to do that. So it's 2 15-week semesters, and then one that I really enjoy is the 8-week field placement. So the month of May and June, you will be on site at a workplace, and we find those workplaces for you. If you're sitting here with a kin degree, that's perfect. That's what you need. If you have more of a health science or a science background, we will be looking for basically anatomy, physiology, some biomechanics, and don't worry about the qualitative design. You have that within your kin undergrad. It's kind of like a research method, some stats. So here are some of the courses that we will be taking, exactly a highly focused ergonomic agenda with not only the practical stuff that I have just talked to you about in terms of theory and practice for ergonomic assessments, but you will get the cognitive side, the human-computer interaction, some UX design, and we also ensure that you get safety in the workplace. Many of the ergonomic positions that you'll apply for are within safety, organized within the safety department, and therefore understanding safety is a key part of that for fitting in. We'll set you all up. Again, human factors in design. You'll get a design project, so you'll be ready to work with the engineers to not only assess the workplace, but also help to implement and design the workplaces so that they reduce the risk of injuries. As I've mentioned, I think that the piece de resistance is the field placement, and we have more companies than I have students. The program is limited to 40 students right now because it's relatively still new. If you have a kin degree, we don't have a minimum requirement, but if we exceed the 40 in applicants, then we would go to a grading system based on your grades. So I think there are tons of opportunities still. Even these are the partners that we send field placement to. And I'm also pleased to tell you that we've got over 85% employment rate. I know that if you know any of graduates from your program, I'm sure that they have, you may know some that are already in the program and graduated. Please contact me. I'd be happy to connect you with some of the grads so you can get some information about the program. But as you can tell, I love ergonomics. I think that the Fanshawe Advanced Ergonomic Studies program is a great fit for kinesiology graduates. And if any of this intrigues you, please apply. The cutoff date is February 1st, so I know that you'll be getting this video in the month of January, so please have a look at the admission, and I look forward to seeing some of you in the future. My email is astevens@fanshawec.ca. I'll look forward to hearing from you if you've got any questions. Thank you.